want to return now to that incredible space story we were talking about a little earlier in the programme. That's because researchers here in the UK say they have found the strongest sign yet of possible life beyond our solar system. They've done so by detecting the chemical footprint of gases in an alien planet's atmosphere that, on Earth, are only produced by living organisms. We're joined now by the lead researcher on the study, Nikku Madhusudhan, a professor of astrophysics at the University of Cambridge. A pleasure to have you with us. So talk to us about this gas you've discovered. Like I say, on Earth, it's associated with bacteria and marine organisms.
That's right. Dimethyl sulfide and dimethyl disulfide, one of two gases which we have found evidence for, are solely from life here on Earth, although we want to be extremely careful in making sure that this is also from life elsewhere. So far, studies have shown that to be the case, but we want to remain open.
Talk to us about how you've made a discovery on a planet 700 trillion miles away.
Yeah, so the method is called the transit method. We have used the James Webb Space Telescope, the most powerful observatory in space ever built by humans. So we use what is known as the transit technique, which is when the planet goes in front of the star, some of that starlight passes through the atmosphere of the planet before reaching the telescope, and imprinted on that starlight is absorption from the molecules in the planet's atmosphere. So using very high precision observations, we're able to tease out the quantity of that absorption, and from that we can tell which molecules are causing that absorption. So it's phenomenal that we're able to do that right now on a habitable zone planet 120 plus light years away.
This is remarkable. So the light emitted from the small sun that this planet's orbiting is heading towards the James Webb telescope. As that planet passes through that stream of light, the atmosphere of the planet alters the composition of the light, and you can detect those changes?
Yeah, it alters this. Yeah, the shape of the spectrum of the light that you're seeing from the star, and then we can detect that.
Can you detect other things in those light signals? Can you detect maybe the temperature of this planet, the atmospheric pressure, the amount of other gases, carbon dioxide, oxygen, that might help to reaffirm the fact that there could be life-supporting conditions?
Yes, indeed. Actually, 2 years ago in 2023, we reported the first detections of carbon-bearing molecules in the same planet with the same technique, but with an entirely different instrument. We detected methane and carbon dioxide, and we did not detect some molecules like ammonia and carbon monoxide. So to this date, over the last 2 years, there has been a lot of debate on what that composition means, and the only explanation currently that explains all the data is one of a Haitian world, an ocean world with a hydrogen-rich atmosphere, and we had predicted that is a condition, that is an environmental condition that could sustain life. We also saw a small hint of dimethyl sulfide in our last observation, but now we went ahead and looked at a completely different wavelength range with a different instrument on JWST, and we are seeing a significantly stronger sign of the same molecule, which is what gives us the confidence. But still, we don't want to stop here. We want to make more observations and be really, really sure that it is not a fluke. We want to be better than like 1 part in a million chance of it being a fluke. So we want to be really sure. But it is very, very exciting and a landmark development in the field nevertheless.
Worth noting, the images we're showing our viewers are of artists' impressions of what this planet could look like. We're not showing actual footage of it. And you talk there about the confidence. And that's something that's really interesting here, because you're currently working at a level of confidence that I think most people will go, OK, well, that's it. It's a done deal. But you need to get to a level of confidence that is almost unparalleled in its strength of confidence. Just talk to us about the number of .99999% that you need to get to.
Right. I mean, right now, the confidence we have is at a 99.7%, which means there is still a 0.3% chance that this could be a statistical fluke. But in scientific discoveries, especially like a discovery like this, which is completely game-changing for science and transforming our understanding of the universe, we want to be absolutely sure, because it affects science and society in so many ways. So we want to go to a 5 sigma level where we want to make sure that there is less than 1 in a million chance of it being a statistical fluke. And then, even if we detect the molecule, it will be very good news that that molecule is there, and it will be a very good sign of life, but we still want to do more experiments, theoretical work to make absolutely sure that that sign is uniquely from life as it is on Earth, and not from some other process that we may not even have thought of so far.
What can you do to try and ascertain that, to try and find other ways that these gases could have been produced? Are there experiments that you can do here on Earth to try and discount other ways that it's formed?
Yeah. So experiments have been done in the past to try these things, but so far we haven't found a result, an experiment or a cosmic result, which can explain the amount of these gases that we are seeing. This is thousands of times more stronger than what we see here on Earth. So we don't have any experiment that can do that right now, that has done that in the past. But we want to design more and more experiments to see if there's a mechanism that can do that. And we want to do theoretical studies as well to find a pathway. But given the magnitude of result, any investment of time and effort we make in this is totally justified, because if it holds true, that will change our view of the universe forever, right? So the sky that we look at today is a physical sky, physical objects, planets, stars, galaxies. But if you find that this is actually true, it is due to life, then what you'd be looking at is a living sky. And that's a major transformation to us as a species. So we want to make sure we do everything we can to establish that we don't make an early claim of life without doing our due diligence.
Like you say, it would change our understanding, our mindset, our vision of the sky beyond our own atmosphere. But without being too morbid, the sad reality is we're struggling to manage to look after the life on this planet. What tangible positive benefits can we derive if we do find bacterial or photoplankton life on a planet 700 trillion miles away? What can we do with that information to really further us as a species, as a planet, as the Earth floating around in this massive dark abyss?
Yeah, so there are scientific implications and there are societal implications. The scientific implication, of course, is establishing the universality of biology. So the laws of physics and chemistry that we know today on Earth, we also know that they apply in the universe out there. We do this with cosmic experiments. But biology has never been proven on a cosmic scale. So it's a very radical, fundamental transformation in our sciences and what we study and how we view our universe. So there is that part. And that would also inform how life originated here on Earth, which is still an open question. So if we can observe many planets with different conditions, whether or not they have life, we could potentially piece together the puzzle of how actually and under what conditions life emerged here on Earth. So that's a scientific aspect. But more on a societal level, I think the fundamental transformation that has to happen and will happen amongst our species, humans, some sooner than others, is that for once we'll realize that we are all representation of the same planet. We are one entity, and that, in my personal view, that should bring us all together as a society, as a civilization.
Really fascinating stuff. Joining us live from Cambridge, Nikku Madhusudhan. Really appreciate you making time for us. Thank you so much.
Thank you for having me here.